Section 4.4 is about division of polynomials. When we have a fraction a over b, we can rewrite it as a divided by b. For example, if we have 3 over 5, then we can rewrite it as 3 divided by 5. In number 2, we have 7 divided by a plus 1. We have a parenthesis. That means this part is a denominator. And 7 is a numerator. So we can rewrite that as 7 over a plus 1. We have x to the 5th power plus 4xy plus 2 divided by y plus 7. Algebraic expressions is on the numerator and denominator. In this case, there are multiple terms, so we have to use parentheses. So open parenthesis, x to the 5th power plus 4xy plus 2 divided by what's in the denominator, but we have to use the parenthesis y plus 7. If we don't use parentheses, the entire meaning can be very different. For example, in the expression in the remark, what it shows is this is one part and this is a separate part. When we convert the expression into the fraction-related expression, what we have to do will be x to the 5th power plus 4xy plus 2, because that's in the denominator, over y. And 7 is a separate number from the division. So we write like this. So those are not the same. Let's review dividing polynomials by a monomial. Let's assume that A, B, and C represent polynomials. Then when two polynomials are added in the numerator, we can separate into two fractions like this. The same when we consider the difference of two polynomials on the numerator, we can separate that into two parts and think about the differences in the fraction. What you have to be careful about is when we consider this case and this case, we have one term in the denominator and we have two terms in the numerator. In this case, we have two terms in the denominator and one term in the numerator. In that case, we cannot separate the new denominators into two fractions. So that is not true. Let's do some example. Divide and simplify. We have negative 19 x to the fourth power v cubed plus 16xv divided by negative 2 x to the fourth power v cubed. It's important to use parentheses here so that we are not confused about which one is the denominator. Let's write the given expression as a fraction form. 19 x to the fourth power v cubed plus 16 xv over negative 2 x to the fourth power v cubed. We have two terms in the numerator, so we can rewrite the fraction like negative 19 x to the fourth power v cubed over negative 2 x to the fourth power v cubed plus 16xv over negative 2 x to the fourth power v cubed. We will separate that into the similar patterns ones with multiplication. Let's rewrite this like 19 over 2 because negative will make positive. And we know those two are the same, x to the fourth power, x to the fourth power are the same, so we cancel those out. And x cubed, v cubed and v cubed are the same, so we cancel those out. And then this one is 2 times 8, so we cancel 2 together. And we have minus here, so I put minus here, and then 8 times x to the negative fourth power times v to the negative 3 power. I put negative to the power when the factor is located in the denominator. So what you have to notice is x is actually 1 power, v is v to the 1 power. So when we add those power, we get minus 3 for x and minus 2 for v. So we can rewrite that as 19 over 2 minus 8 times x to the negative 3 power, v to the negative 2 power. So that's 19 over 2 minus 8 over x cubed v squared. This is negative, so I located x and v in the denominator. Let's learn about a long division. Before we perform long division, let's review the terminology. When a fraction is written in the form of a plus b over C. A is called quotient, and B is called a remainder, and C is called a divisor. Let's go through the long division with 5 over 2. When we do a long division, we write short vertical line here and a little bit longer horizontal line here. And the number located under this horizontal line will be what's in the numerator. On the left side, we will locate what's on the denominator. Then what we will think about is the number whose multiplication with 2 is less than 5. But when we subtract that number from 5, that number must be less than 2. Here, based on the terminology, this one is divisor, and this one is quotient, and this one is remainder. This one is must be less than the divisor. When we have this result by doing the long division, the way we will write this will be quotient, so 2 plus remainder 1 over divisor 2. Let's summarize it. Quotient is 2 and remainder is 1 and divisor is 2. Divisor is was in the denominator. Divide by 2, so divisor. Next problem is a little more complex pattern. We consider the division of 8x cubed plus 7x squared minus 12x to the fourth power plus 5 minus 14x divided by negative 4x squared plus 5. What we want to do is we want to write the answer in a form quotient plus remainder over divisor. When we perform the long division with this pattern, what you have to be careful will be you have to organize the given polynomial in an orderly manner, meaning you have to organize the terms from the highest degree to the lowest degree. Let's determine the degree of the polynomial. When you look at the degree of the polynomial, the highest degree term is this term, not the first term. So this is a degree 4 polynomial. And what we want to do is we want to rewrite that in an orderly form. Negative 12 x to the fourth power, degree 4, and then degree 3 is 8x cubed, degree 2 is 7x squared, degree 1 is 14x, and degree 0 is a constant term, 5. And then we do something similar we did with number. Let's copy negative 12x to the fourth power plus 8x cubed plus 7x squared minus 14x plus 5. And then it is divided by negative 4x squared plus 5. This is already orderly manner, starting from degree 2, and then this is degree 0. So that becomes negative 4x squared plus 5. To perform the long division, what you have to do will be you will compare the first term. And then you will figure out what you have to multiply to make this one, what appears as a top degree. Obviously, you have to multiply by 3x squared, then negative 4 times 3 will make negative 12, and x squared times x squared will make x to the fourth power. Then what you have to do will be you will have to write those multiplication right here. It'll make degree 4, so I will locate that under x to the fourth power. So negative 12 x to the fourth power. Not only that, you have to think about the multiplication with this. Then you will have 15x squared, and degree 2 term is located here. So I would locate 15x squared right here. Then what we have to do will be subtract from the first line to the second line. When we do that, the first term will cancel each other. And when we subtract, eight x will remain the same, and 7 minus 15 will make minus 8x squared. Then we will just write minus 14x plus 5. Then what we have to do will be we have to focus on this one. After you write this part, you will forget what happened in the first block. And then you will repeat the process. We will compare negative 4x squared with the first term, 8x cubed. If you multiply by negative 2x, then you will obtain 8x cubed. So we will choose to write minus 2x there. Of course, what we are doing is a plus minus 2x. So what we want to do is we want to multiply this negative 2x with negative 4x squared plus 5 and write down here. Negative 2x times negative 8x squared will make 8x cubed. And then negative 2x times 5 will make negative 10x. But we should locate that right under 14x. So negative 10x because of the degree. And do the same process. We subtract from the first line to the second line. Then the first term will vanish. And if nothing appears right below, then we will just write the same. Negative 8x squared, negative 14 minus 10 will make negative 4x plus 5. Then do the same process. This time, the degrees are the same, 2 and 2. So we have to multiply by just a number. We will multiply by 2, then we will get negative 8x squared. So I would add 2 here, then I will focus on this number. Just we are moving on to this stage. We forget everything that happened previously. Just we solely focus on 2 times divisor, negative 4x squared plus 5. Then this time we realize that the first term will become negative x squared. And when we multiply this number with the next one, we will get 10. So plus 10. And we keep subtracting. Then these two will cancel each other. And then the next one is negative 4x minus 5. As I said before, each part has name. This was a divisor which appeared in the denominator, is divided by, this is divisor. And this part is quotient. And this one is a remainder. So when we write the final answer, as it is asked, that'll be 3x squared minus 2x plus 2 plus minus 4x minus 5 over minus 4x squared plus 5. This is the final answer. Let's do the example. Divide 4x cubed plus 2x squared minus 12x minus 5 divided by 2x plus 2. Here, the divisor is 2x plus 2. When we perform the long division, it looks like 4x cubed plus 2x squared minus 12x minus 5 and 2x plus 2, the divisor on the left side. As I said, we start the problem by comparing the top degree term and this one. Other important point you have to make sure is all the degrees are organized from highest to the lowest. This is degree 3 polynomial. It is well organized from degree 3 to 1, 0. So if we consider the multiplication, then we have to write 2x squared here. Then I said you will think about the multiplication with divisor. So it becomes 4x cubed plus 4x squared by multiplying like this. And then we have to subtract from the first to the second. The first term will cancel each other, and 2 minus 4 will make negative 2x squared, and then minus 12x minus 5. Then we repeat the process. We forget everything. Then we consider comparing this term with the divisor. To make the first term the same, we have to multiply by negative x and do the same. So let's write it down as plus minus x. And then we think about the multiplication with this one and divisor. Then we get negative 2x squared minus 2x. When we subtract, we will have minus 10x, because this minus and minus will make positive, so negative 12 plus 2 will make negative 10, minus 5. Lastly, we compare this one with 2x. Obviously, we have to multiply by -5, so let's write plus -5 here. Then this one will become -10x minus 10. We subtract, then the first one will vanish. And then this minus and this minus will make positive. So -5 plus 10 will make 5. We know that this one is divisor because that is divided by. So this one is divisor. And we know that this one is quotient. And this one is remainder. So quotient is 2x squared minus x minus 5, and remainder is 5. If we express this one as a form that appeared here, then we can rewrite it as 2x squared minus x minus 5 plus 5 over 2x plus 2. Let's suppose that the similar pattern of the problem is given as 4x squared minus 12x minus 5 divided by 2x plus 2. In this case, everything is the same other than one of the term is dropped when we compare with the previous example. This is degree 3, and this is degree 1, and this one is degree 0. So it skips degree 2. The natural question will be how to express that in a long division form. When we solve this type of problem, it'll be 4x cubed, and this is degree 3, and degree 2 is missing. So we will make a space here, and then minus 12x minus 5. So meaning space. Rather than make all the things close to each other, and left side is 2x plus 2. And we do exactly the same thing. So it becomes 2x squared. And then when we multiply like this, we will have 4x cubed plus 4x squared, and subtract, and the first term will vanish. And that's in the degree 2 position. Nothing appears here. then we will subtract. So negative 4x squared minus 2x minus 5. And then we do the similar calculation. We focus on here and compare these two. Then that'll be minus 2x and let's write plus minus 2x. Then we think about distribution. So that'll be negative 4x squared minus 4x. Subtract, then those two will cancel each other, and minus minus will make plus, and then it'll be 2x minus 5. And then we have to compare this number with this number again. Then we end up getting plus 1. And when we think about the multiplication with divisor, we have 2x plus 2. And when we subtract, we have negative 7. So in this case, we can express this one as 2x squared minus 2x plus 1 plus negative 7 over 2x plus 2. So quotient is 2x squared minus 2x plus 1, and remainder is minus 7. The highlight of this remark is if there is a degree which doesn't appear in the given algebraic expression, then you have to make a space when you write a long division. Synthetic division is used when we divide by the first degree polynomial that can be written as x minus r. Let's do some examples. Use synthetic division to divide 3x squared minus 14x minus 10 divided by x minus 2. As you can see here, this is degree 1 polynomial without any coefficient to x. What you will do first will be you will put the divisor as 0 and solve the equation. Then you will get x equals 2. To set up the synthetic division, you will draw a longer vertical line and horizontal line. And when you see here, this one is degree 2, and it has coefficient 3, negative 14, and constant term negative 10. This is a degree 2 polynomial, so what we will do will be we will locate the coefficient of degree 2, 1, 0 terms in an orderly manner. So this becomes 3, negative 14, and negative 10. And when we solve the divisor that it becomes 2, we write 2 here. To perform the calculation, what you will do will be just write the first term as it is, then that is 3. Then we consider the multiplication between 2 and 3 and write it here. Then that is 6. What's important here is instead of subtracting from the first line to the second line, we add. If we add both, then we will have negative 8. Then we forget what happened previously and we solely focus on the relationship between negative 8 and 2. And then we multiply these two numbers and locate in the second line. Then that'll become negative 16. And do the mechanical process, we add both and write here, then that is negative 26. What's important at the starting point is writing the coefficient of each term according to the degree. It must be descending degree. And instead of subtracting, we have to add. When we have this consequence, we have to interpret what it means. The last number is a remainder. And first two number, first whatever the other part is, that's something to do with quotient. We start from here. This is degree 0, and this is degree 1. So when we write the quotient, that'll become 3x, because 3 is degree 1, minus 8. And the remainder is negative 26. In the next problem, use synthetic division to find the quotient and remainder when x cubed plus 11x squared minus 5x plus 6 is divided by x plus 6. Firstly, we want to set up an equation, x plus 6 equals 0, and solve for x, then it'll be negative 6. And then draw the long vertical line and longer horizontal line and organize things in an orderly manner. This is related to divisor, so we will locate that on the left side, and then we will consider the coefficient. Then it's degree 3, and degrees are organized in an orderly manner, 3, 2, 1, 0. So we copy the coefficient 2 and 11, -5, and then 6. And I said you have to write, just copy 2 under the horizontal line, and then you start to multiply. -6 times 2 is -12. And then when we add both vertically, that is -1. And then we do the same thing. We multiply these two, -6 and -1. Then we will have 6. And then we add them up to get 1 here. And then we multiply -6 and 1 and write here. Then we have -6 here. When we add them up, we will have 0. What does that mean? The remainder is 0. When we consider the degree, this is degree 0, degree 1, and degree 2. When we combine those, it'll be 2x squared minus x plus 1. This one is the quotient. And remainder is 0. Usually in this case, we write it as 2x squared minus x plus 1 because there is no remainder. But if we want to clarify what the quotient remainder, then we can rewrite that as 2x squared minus x plus 1 plus 0 over x plus 6. Because this is remainder. And this is divisor. And this is quotient. When we have a division, x cubed minus 5x plus 6 divided by x plus 2, we can apply the synthetic division. What we know is the numerator is degree 3. And when we solve for x, we get x equals -2. When we write to perform synthetic division, I said the coefficient must be written in an orderly manner. In this case, from degree 3 and then 2, 1, 0. Obviously, on the left side, we have to write -2. But what's ambiguous here is there is no number in front of x cubed, and there is no degree 2 term here. So for clarity, what we can write is with coefficient. So 1x cubed, the next degree must be x squared, but doesn't appear, so it is 0 times x squared minus 5x plus 6. So that is 1, 0, minus 5, and 6. So we write 1 here, and then when we multiply these two, that will be minus 2, and add them up, then minus 2, and we multiply these two to get 4, and when we add them up, we will have minus 1. And lastly, when we multiply these two, and right here we have 2, so the remainder is 8. So when we interpret the quotient will have degree 2, because when we interpret degree, this one is degree 0, 1, 2. So quotient is x squared minus 2x minus 1, and the remainder is 8. So we can rewrite that as x cubed minus 5x plus 6 over x plus 2 equals x squared minus 2x minus 1 plus 8 over x plus 2.